Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Morning.
Good morning, sir.
Morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning. Okay.
Good morning, sir. Good morning, sir.
Good morning, Ajay.
Good morning, sir.
Good morning. Okay, so this is a neat class. We are discussing physiology first, transport in plants. Okay, the transport in plants. Just a minute, I have to share the screen first.
Sir,
Okay,
in
this is
permeability, we have
the
completed up to
reproduction.
impermeable membrane.
Impermeable membrane. Okay, suberized cell wall. No? Plant physiology, transport in plant. Okay, impermeable membrane. Right. Now, next is semi-permeable membrane. Okay.
Excuse me, sir.
Hmm.
What is cutinized and pulverized cell wall, sir?
Cutin, if the wall has deposition of cutin, okay, cutin layer is formed around the wall. So it is cutinized cell wall. Generally, cell wall has cellulose only. Okay, the main component is cellulose. But if cutin is there, if it surrounds the cell wall, it is cutinized cell wall, means cellulose content is very low. So it is called cutinized. Sometimes suberin material, that is also impermeable actually. So if suberin is deposited around the cell wall, it is called suberized cell wall. Are you aware of cork? Cork. Okay.
Yes, sir.
That cap, bottle cap. Okay. In the mostly you can see in chemistry lab. So that cork is actually suberin. That is suberin material. Okay. So it cannot allow anything through this. So that is suberin, suberized cell wall. Okay. Semi-permeable. Semi-permeable membrane. Definition, as you know, this is the membrane. It allows both solute and solvent. It is permeable, sorry, semi-permeable. No? Okay, so it is impermeable for solutes. No solute is allowed, and permeable for solvent. Okay, so that is called semi-permeable membrane. Okay. Example of semi-permeable membrane is parchment paper, goat's bladder, Goat's bladder means the membrane of the bladder, urinary bladder. So that bladder has that membrane which is also semi-permeable. Goat's bladder so these are two semi-permeable membranes. Then the last one is selectively permeable, that is called differential permeable. Selectively, or sometimes it is called differential. Means depends on that size of solute. Mostly they allow a smaller one, okay, but large molecules like polysaccharides, okay, protein, polysaccharide, lipids, they are not allowed through the membrane. So this membrane allows, means it is selective, okay, so it is permeable for gases or ether or alcohol, means these are actually solvents, alcohol, ether, water, but it is impermeable for large molecules.
Sir, can you scroll up, sir?
This is starting of the class from semi-permeable membrane. Okay. Next, selective permeable. This membrane allows, or it is permeable for solvent and selected molecules of solute. Okay. It allows alcohol, sorry, it allows alcohol, water, H2O, and ether to pass through it. But it is impermeable for large molecules such as protein, lipids, especially phospholipid, and polysaccharides. And polysaccharides. Okay. So the example is plasma membrane. Plasma membrane or cell membrane is the selective permeable membrane. Fine. This is selective or differential permeable, means it can differentiate the solute molecules. Okay, only smaller molecules can be passed. Otherwise, it doesn't allow the large or heavy molecules, you can say, like protein, lipid, or polysaccharides.
So then
But
how
yes,
does
solvents are
liquid cells cover cells, sir?
Hello.
Sir, how does proteins and lipids enter our human cells, sir?
No, not directly. Their monomers can be allowed. No? That is why it is selective permeable, not direct protein. Okay.
Sir,
So
can you
Sir, in the
please
second
scroll up the
point,
page?
sir,
uh,
in the second point, what is it allows alcohol, water, and what is that word? Sir?
ether, ether,
Okay. Sir.
ether. These are solvents actually. Organic solvents are also allowed, no? Alcohol, ether.
So what
So
is
What
ether?
does ether mean, sir?
this is chemical, no? In chemistry, in organic chemistry, you will see ether, CH3OCH3. This is the formula, ether. Alcohol, C2H5OH. So these are liquid chemicals. Okay. There is
Okay.
a separate chapter in organic chemistry, ether. Alcohol, ether. Okay. Formaldehyde. Fine. So this is ether, one chemical actually. It is also solvent, organic solvent.
Okay, sir. Thank you.
Fine. So they
Sir,
can
can
be
you
allowed.
show the C1?
See, semi-permeable membrane.
Yes, sir.
So these are different types of membranes on the basis of their permeability. Okay. Now next term is osmosis. Fine. Osmosis. So as you know, okay, tell me what is osmosis? Osmosis means
Movement of water molecules from higher concentration to lower concentration.
okay,
Moment
from
of
higher
molecule.
concentration.
Movement of water from selective permeable membrane.
Okay, from higher concentration to low concentration or low concentration to high concentration.
Higher
Concentration to high concentration.
Uh,
Higher
Low water concentration to high water concentration.
Low concentration to high concentration, sir.
from dilute solution to concentrated solution. Yes, that is called osmosis. Fine. Just a minute. Okay, just a minute. This is osmosis. So osmosis is actually here. Just a minute. First of all, definition. So definition says that this is movement of solvent, just diffusion. This is also diffusion. So the diffusion of the solvent from its higher concentration to its low concentration. Okay, or you can say uh, the region of high potential, high chemical potential to low chemical potential. Okay, that is called osmosis. But here the semi-permeable membrane is required. So through the semi-permeable membrane, okay, then it is called osmosis. This is the diffusion of solvent from a dilute solution to concentrated solution through semi-permeable membrane. It is the movement of
So can you explain the
Water
first point?
molecules. Just a minute. It is the movement of water molecules. Means, in other word, I'm defining this. The same point is here actually. The same concept is here. It is the movement of water molecules from their higher concentration. From their high potential. Region to low potential region. What does it mean? In first point, diffusion of solvent. Solvent means water. Okay. Or you can take any alcohol or ether. So this is solvent. So the solvent, it moves from a dilute solution. Dilute solution, what does it mean? Dilute solution, it means more water, more solvent is available. No? Less solute, more solvent. It is a dilute solution. If you are adding more solute in the solvent, it becomes concentrated. Fine. So it means, suppose for example, if the sugar solution is there, only 1 teaspoon sugar is added, suppose. Okay, that is a solution. Okay, it is dilute solution. Fine. Now if you are adding 2-3 tablespoon of this sugar, fine, so it becomes more concentrated, means you are adding solid molecules, so it becomes more concentrated rather than the first. Okay, so first that was dilute, but now if you are added some if you added some sugar, more sugar, it becomes concentrated. So here in this definition, the movement of solvent from dilute solution to concentrated solution. Okay, it means in this area where solvent molecules are more. Okay, so in first solution where only 1 tablespoon sugar is added, it is dilute, rather than as compared to the other solution where 3-4 spoon sugar is there. So it means water moves from this dilute solution to concentrated solution. It means solvent molecules, they move from their higher concentration, from their higher energy, or you can say from their more potential, high potential, to their lower potential area. Okay, just like this. This is a membrane. Yes, one more. Through semi-permeable membrane. That is important. Huh? Otherwise, it is not osmosis. So here diffusion occurs through the semi-permeable membrane. This is semi-permeable membrane. And this solution is dilute solution, suppose. Okay. And the second solution is concentrated. This is concentrated solution. So obviously water moves H2. It moves, these molecules move from dilute solution to concentrated solution. Okay. It is just like that experiment. Suppose one beaker is there.
Hypertonic and
outer
hypertonic.
solution. Yes, hypotonic and hypertonic. So this is outer solution which is hypertonic now.
Hypertonic.
So
And inside
yes,
hypotonic.
yes, and here the water moves out. That is called exosmosis. Okay, it means water moves towards the area where water molecules are less. Clear? So if water molecules are less, from the other solution, the water moves to that area, towards that cell. Okay, so this is the process that is called osmosis. So you can say this is dilute solution, this A is dilute solution, and this is concentrated solution. Okay, so from dilute solution to concentrated solution through the semi-permeable membrane, or in other word, the water moves from its high potential. So here it is high potential now. High potential level to low potential level. Okay, So in other words, you can say high potential to low potential. Fine. This is osmosis through the semi-permeable membrane. This is semi-permeable membrane, SMP.
Sir,
So this is semi-permeable. Huh?
sir, in the first point, after this solution through semi-permeable membrane, that point, the diffusion of the solvent from dilute solution to, after that, what's the word, sir?
Concentrated, CONC.
Okay, sir.
This is abbreviation. I used abbreviation only. Here MEM means membrane. Huh? Generally, I use short form or abbreviations. CONC means concentrated solution. Okay. So this is osmosis. Fine.
Sir, what is
It
that
shows
SMP?
Semi-permeable membrane.
SMP, semi-permeable membrane. Semi-permeable membrane.
Sir, then it should be SPM, right?
No, yes, sorry. SPM. Yes. It is SPM. Semi-permeable membrane. Okay. So this is
Okay.
osmosis. Fine. And it was discovered by, means this phenomenon was discovered by Nollet. Not important because in NEET generally they do not ask like scientist's name. Okay. They removed this concept. Okay, generally now they do not ask scientist name or discoverer names. But yes, it was theoretically it is important. So osmosis
Sir, so in boards they'll ask, sir,
was,
the scientist and discoverer's name.
I have no idea about boards, but in NEET it is removed completely. So you have to memorize this one, no? Maybe in board they ask, means because different boards they have different criteria, different policies. So here in Telangana, I have no idea about this. Osmosis was discovered by Nollet. Okay. Fine. Now there are two types of osmosis, as you know: endoosmosis,
Exoosmosis.
exoosmosis. Yes, first is endoosmosis and second is exoosmosis. Endoosmosis, it means this is absorption of water by the cell, or you can say entry of water molecules into the cell sample.
Exoosmosis.
Intake of water. This is exit of water molecules from the cell. So it is exoosmosis. So endoosmosis, it means
Sir, can you scroll it up, sir?
It is intake of water in the cell. Into the cell or cytoplasm. If the cell kept in a hypertonic solution or hypotonic solution?
Hypo.
Hypo. Okay. No, it is hypo. The outer solution should be hypo. Yes. So that endoosmosis can be possible. If the cell is kept in a hypotonic solution, its outer solution should be diluted. hypotonic solution water enters the cell by endosmosis. So what happens? The cell swells up. Okay. Fine. So this is endosmosis. For example, this is a beaker, hypotonic solution. Hypotonic solution means water. Okay. And if one cell is there, it has higher concentration of protoplasm. So obviously water enters the cell. It enters the cell from the surrounding. That is endosmosis.
So once, please, can you scroll up?
The cell shape is hypertonic, and this process is called endosmosis. Yes,
So the cell get ultimately turgid, right?
turgid. Yes, it swells up and shows turgidity. Means it becomes turgid. Okay, turgid in case of plant cells. Okay, in animal cell the problem is cell wall is absent, so it will not be turgid. Okay, it will burst in case of animal cell because they have only plasma membrane. No?
Yes, sir. Yes.
If you keep one RBC in the water or any hypotonic solution, so water enters the cell and finally it bursts. Okay. So this is also one question in NEET. So plant cell have cell wall, it resists that pressure of turgid, that is called Turgor pressure, TP. Okay. So it creates another pressure, equal and opposite pressure, that is called WP, wall pressure, against the Turgor pressure, so that it becomes turgid, but it cannot be burst. Okay, this is endosmosis. Next is exosmosis.
Sir, our cell wall is absent in animal cell. What happens?
The cell will burst.
Okay.
The cell will burst. Okay, because plasma membrane cannot resist that power, Turgor pressure. Okay, so it will be burst.
Sir, means
Okay.
are the both pressures equal, sir? Cell wall pressure and target pressure?
It is equal and opposite. Yes, equal and opposite. If Turgor pressure increases, on the opposite side, wall pressure increases. Okay.
Okay, sir.
And both are against to each other, no? So that the cell cannot be burst. Means cell wall protects the cell in that condition. Okay, exosmosis here, just opposite term. Here, exit of water.
Sir, can you once scroll up?
It is exit of water from the cell sap or cell. Okay, that is called exosmosis. For example, if the cell is kept in hypertonic solution, Okay. It will shrink it will show shrinkage, or it will be shrink. Due to exosmosis. So exosmosis occurs. Okay, if you are keeping this cell in the sugar solution or any hypertonic solution, suppose. So in this case, the inner solution or the cell sap is hypotonic and the outer solution is hypotonic. But outer solution is hypertonic as compared to the cell sap. So water moves out from the cell, and this condition is exosmosis. So this is hypertonic solution, and the cell sap, it behaves like hypotonic, and because of this it results in exosmosis. Clear? So these are of two types of osmosis: endosmosis and exosmosis. Now pressure, osmotic pressure.
Sir, can you show endosmosis?
Just a minute. Endosmosis. This is endosmosis.
Sir,
Endosmosis, exosmosis. Huh? Hello.
back then your screen was soft.
Your voice is not clear. What are you saying? This is endosmosis. I repeat this. It is intake of water into the cell. If the cell is kept in hypotonic solution, okay, so water enters the cell by endosmosis. The cell swells up, it becomes turgid. Exosmosis, it means exit of water from the cell, and if you keep the cell in a hypertonic solution, water moves out. That is shrinkage of the cell. Exosmosis. Plasmolysis occurs finally. Huh? Now osmotic pressure. Osmotic pressure. Yes.
Sir, in exosmosis, when it is kept in hypertonic solution only then it shrinks, or in any solution it shrinks?
No. If water moves out by any reason, okay, and the reason is only one. If you keep the cell, if you place the cell in that environment where outer solution has more solute, okay, it is more concentrated. So in that condition, water moves out, okay, according to that osmosis definition. In osmosis definition, it says that water movement occurs from the dilute solution to concentrated solution through the membrane. Okay, so obviously here the reason is only osmosis. Fine, in an exosmosis
Yes, sir,
as well as an endosmosis, both.
So only in hypertonic solution it shrinks.
Yes. If the environment is dry, that is a different point. Environment is dry, suppose. Okay, so again, the inner solution, it becomes concentrated. Water moves out. In case of stomata, in transpiration, water moves out. Okay, in the form of water vapors. Fine.
Sir?
So that
Yes,
is.
sir, got it.
Yes.
In this exosmosis, the useful components and minerals in water, they also just moves out.
No, not
Stay
minerals.
contains
No, not
in the
minerals.
cell. Okay, just the simple water
Water,
without
only
any
water.
mineral.
Yes, yes, yes.
Okay.
Without any mineral. Other components, they are plasmolized. Okay, they are concentrated in that liquid material that is ground substance, that is protoplasm. Okay, so
Yes, sir.
protoplasm become constricted with minerals and other elements, other components. Fine. So that is
Fine, sir.
concentrated part, that is plasmolysis. This is another definition after osmosis. So because of exoosmosis, plasmolysis occurs. Okay, but during osmosis, only water moves out, no other substance. Okay, what is osmotic pressure? So osmotic pressure, this is the pressure which is exerted by that solution, or you can say that solute, uh, to enter that, to prevent the entry of water inside the solution. Okay, that is called osmotic pressure. So the pressure which is required to prevent the passage of water into the solution, means solution creates that pressure, solute molecules, they create that pressure which inhibit the entry of water, okay, into the solution. That is called osmotic pressure. Okay, or in other word, you can say this is the thirst of that solution, thirst of that solution, by which they can absorb. In this solution can absorb more water. That is the power of absorption. Okay, so this is the power of absorption of that particular solution.
Double H.
What is this? Okay. Yes. So osmotic pressure. Osmotic pressure, it is the pressure this is the pressure applied to prevent the entry of the entry of solvent into the given solution by osmosis. Okay, so it is the pressure exerted by that solution, okay, to prevent, to inhibit, to check, to stop the entry of solvent molecules into it or into the solution. Okay, it generally it is used to express the concentration of solution most of the time. Okay. Usually osmotic pressure expresses hello. Yeah. Regarding
Sir, just remove them, sir. It's so irritating.
just a minute. So osmotic pressure is usually expresses the concentration of solution. Okay. Osmotic pressure shows the tendency of a solution to take pure solvent or water through osmosis process. Okay. So this is osmotic pressure. It means if one, suppose, okay, this is osmosis, dilute solution, concentrated solution. Okay, this is concentrated solution. We know water moves from dilute solution to concentrated solution. Okay, this is movement of water. So movement of water from dilute solution to concentrated solution. If we are increasing concentration of this solution already concentrated, if we are increasing concentration of this solution, osmotic pressure increases. Okay, osmotic pressure increases, and it shows the thirst of that solution to absorb more and more water. Okay, but the definition is slightly different. Okay, the definition says that this is the power, this is the pressure to prevent the passage of water into the solution. Okay, it means solid molecules, these are solid molecules, so they exert a pressure on the wall. Okay, to stop the entry of water. Fine, but on other hand, it shows the tendency of solution to absorb more and more water. If concentration is more tendency, more thirst of that solution to absorb water. It means water moves fast. Okay, if you are increasing concentration on other side, concentrated solution, this is A, dilute, this is B. So if you are increasing concentration of B solution, it means you are increasing the rate of osmosis. Okay, the rate of osmosis increases. if osmotic concentration, osmotic pressure increased. Suppose these are two cells, for example. Okay, these are two different cells. They are placed in one system, one medium. This is A, this is B, and it has less OP. It's OP, the B. B cell has more OP than A. Okay, in that condition, water always moves from A to B. Both have osmotic pressure, but the osmotic pressure of A is less than B. So B absorb water. It has more tendency to absorb water. Okay. This is the concept. Actually, on this concept, many questions they form.
So can you repeat?
Can
I
you
didn't
hear me?
understand.
Sir, once can you scroll down?
Okay. So osmotic pressure, just osmotic pressure. This is osmotic pressure. Osmotic pressure means this is the pressure applied by solution, or you can say solute, on the wall. A wall means the plasma membrane. So on the membrane, on the wall, to restrict, to inhibit, to prevent the passage of water into the solution. Okay. Through this semi-permeable membrane, osmosis occurs now. So it means it prevents that osmosis. It prevents that water molecules entry into the solution. Fine. But on the other hand, this osmotic pressure, it shows that tendency of the solution, tendency or power of that solution to absorb more water. If concentration is increased, concentration of solution increased, it means it is more thirsty. It means it can absorb more water. At rapid rate, it can absorb more water from the next solution or from the surrounding. Okay, through the semi-permeable membrane. For example, in this case, this A solution is dilute solution, more water is here, and in this solution it is concentrated, more solute is here. So these solid molecules, they exert one pressure on the wall to prevent the entry of water into the solution. That is called pressure, osmotic pressure. It means in B solution or in B cell, osmotic pressure is high. Okay. It shows its thirst. It shows its tendency of absorption. Okay. Tendency to absorb more water. So for example, we take two cells. This is a dilute solution wala cell, and the B cell, it is concentrated solution. So it means both have osmotic pressure. It is not pure water, it is solution, but less amount of solute is dissolved in this A cell. In B cell, more solutes are available. So in that condition, water moves always from lower concentration, or you can say lower osmotic pressure, to high osmotic pressure. Okay, so it moves from A to B always. Yeah, it shows osmotic
if the
pressure.
osmotic, if it is high, then it has the potential to absorb more water.
Yeah, to absorb more water. Yes, it shows that the thirst or power of that solution to absorb more water. Okay. So,
Sir, can
this
you
is
repeat the
osmotic.
last point?
The last point is here, if we are taking two cells, if we are comparing these two cells or their osmotic pressure, suppose one cell is dilute solution, the cell is dilute, it means more water is here. So its osmotic pressure is less as compared to the other. So the other cell, B cell, has concentrated solution, more solute and less water is available. It means osmotic pressure is high, means that pressure which is exerted by the solute. If the solute molecules are more, it means osmotic pressure is more, obviously. Okay. Suppose if you are pushing a bus, if you are pushing a car, okay, so only one person can push the car, and if we are comparing with this this condition, if the 2-3% or 10%, if they are pushing the car, okay, so where is pressure, where the pressure is more? In second condition, if 3-4 persons are pushing the car, okay. Similarly here the solid molecules, they push or they exert a pressure on the wall. If you are increasing solid molecules, it means the pressure always increases. Okay. So B has more pressure, more osmotic pressure. Okay. And because of this, osmosis becomes fast. Rapidly the water molecules enter this cell. So here from A to B, the movement of water occurs. Okay. This is osmotic pressure. Here. Fine. Now osmotic pressure in different plants, it is
Okay, ma'am.
fine. So here osmotic pressure, it is different. It has been reported in different plants. Fine. So the osmotic pressure, it is maximum in halophytes. Okay. Are you aware of these terms? Mesophyte, hydrophyte, xerophyte, halophyte.
Yes, sir.
No, sir.
What
No,
is
sir.
halophyte?
We don't know, sir.
No, sir.
Nobody?
No.
sir.
Halophyte means
Halo.
the desert plants.
No.
The
Which
desert
plants?
Desert plants.
The term is xerophyte or hydrophyte. Okay.
Hydrophyte means those live on the water.
Water, yes. Aquatic plants. So aquatic plants are hydrophytes. Xerophytes means the desert plant. Okay. In dry soil, sandy environment. Okay. So xerophytes means in dry condition or where water scarcity is there in the soil. So that is xerophyte. Mesophyte means normal condition, average condition. Okay. So the surrounding environment, it is mesophyte. Okay. And halophytes. Halophyte means these
Salty
plants,
condition.
they are in that area where saline solution or saline water or saline soil is there, means more salty. Okay. Salt is more in that area. Minerals are more. So that is called halophytes. So these are 3-4 different terms. Halophyte means the plants growing in that area where minerals are more, means actually concentration of soil is more. That is called halophyte. Hydrophyte, as you know, hydro means water, hydro. So aquatic plants. Xerophytes, xeric condition, XERIC, xeric. Xeric means dry, desert. Okay. So this is desert condition. Mesophyte means normal, medium condition, optimum temperature, optimum water. So that is mesophyte. So here,
What's halophyte?
this is the halophyte.
Yes, sir. What halophyte?
Growing in that area where saline soil is there. Saline soil means more concentration. The solution means the soil solution is more concentrated, means minerals are more. Okay. So that is halophyte. Salty soil, you can say. So that is halophyte.
Sir, can you please scroll a bit up?
Sir, what is gradient of concentration?
Osmotic pressure. Hello.
Sir, gradient of concentration.
Concentration gradient. Gradient means difference. Concentration gradients. If you are comparing two solutions, okay, so their concentration gradient is there. So that one should be hypotonic, another is hypertonic. Okay. If there is no concentration gradient, it means there is no difference. So the solutions, both the solutions become isotonic. So gradient means difference between two. Concentration gradient. That is difference between two concentration of the solutions. That is called gradient. Osmotic pressure is maximum in halophytes. Obviously, in these plants, because these plants are growing in that area where more minerals, more salt is present in the soil. So they maintain that that condition. They maintain that one concentration in their cell by storing more salts. Okay, so they maintain that proportion. They maintain that equilibrium. So they are called halophytes. So osmotic pressure is maximum in halophytes. It is minimum in hydrophytes. Hydrophyte means aquatic plants. Okay, so it means more water is available in their cells. So less osmotic pressure. Dilute solution is there, less osmotic pressure. So these are hydrophytes. They have minimum.
Sir, can you say again what are halophytes? Can you say what are halophytes?
Just a minute. I will mention all these terms. Just a minute.
Okay.
I will write all these terms so you will get easily. Just a minute. This is halophyte. Then xerophyte. Then mesophyte. And then hydrophyte. These are four different types of plants. Okay. There are so many variations, adaptations of the plants. Okay, you will see in ecology. Okay, different adaptations are possible. Chrysophyte, cryophyte, zomophyte. Okay, but here these are four main categories: hydrophyte, mesophyte, xerophyte, and halophyte. Yes.
Okay.
Is it completed?
Yes, sir.
Yes, sir.
Okay. This is a mesophyte. Mesophyte, it means actually these terms are related with the ecology. Okay, mesophytes means the plants grow in normal environmental conditions means optimum conditions, normal temperature, normal soil solution, normal concentration. Okay, water is sufficiently available. So that is mesophytic condition. So all these plants generally we see in surrounding, that is mesophyte. Xerophyte. Xerophyte, it means the plants grow in xeric condition, dry condition. Xeric condition means desert. Okay, so if they grow in dry, xeric or desert, that is called xerophyte. So cactus, opuntia, okay, these are xeric condition, means these are xerophytes. Next is hydrophyte. What is hydrophyte? The plants grow in water. or you can say aquatic condition. Water condition means aquatic condition. Huh? And the last one is halophytes. What is halophyte? Halophyte means the plants grow in saline soil where concentration of soil solution is more than plant cell. Okay, these are halophytes.
Sir, can you show from mesophyte, sir?
This is mesophyte. All four terms: mesophyte, xerophyte.
So can you give an example of halophyte?
These are euphorbia. Just euphorbia.
Sir, what is meant by saline soil?
Saline soil means concentrated soil, means salts, minerals are more than cell. That is saline soil. Overall concentration of soil is more than the cell. Okay, that is
Sir,
saline.
halophytes means the seashore plants, right?
Yes, very good. Actually, that is estuary. Okay, in West Bengal there is a region, Sundarban. Okay, so this Sundarban region is an estuary actually. Estuary means here brackish water is available. Brackish water, what does it mean? It means mixture of fresh water and sea water. Okay, marine water. So that is estuary, or seashore you can say.
Sir, do
Seashore is
mangroves come
also
in
one
this?
example, and Sundarban.
Sir, do mangroves come in this?
Yes, mangroves. Very good. You have the idea. So these are halophytes. Okay, mangroves. And the example of mangrove is euphorbia. Just a minute. So example is mangrove. Means these plants in that environment, they are called mangroves. So mangroves, in mangroves, euphorbia. Euphorbia is the example. Mangrove. Okay. They have different types of habitat. Fine. Their habitat is different. Mangrove environment, mangrove soil. So they have some adaptations to survive in that condition. These are halophytes. So halophyte, hydrophyte, xerophyte, mesophyte. It means the halophytes, they have maximum osmotic pressure to maintain that equilibrium with that soil solution. Okay. Fine. In short, osmotic pressure, it is maximum in halophytes and minimum in hydro. Okay. Next, after osmotic pressure, one more. It is DPD. Okay, what is DPD? Diffusion pressure deficit. Or before this, endosmosis, exosmosis occurs now. So before this, DPD, we should discuss turgor pressure and wall pressure. Okay. Otherwise, DPD will not be completed. Okay. Just a minute. First of all, turgor pressure and wall pressure. So next term is turgor pressure.
So once, can you show halophyte?
This is halophyte. Turgor pressure. What is
The
turgor
pressure exerted by the cell
Turgor
content to the cell wall.
Cell content to the cell wall. Actually, the pressure exerted by entering water. Okay, water entered the cell. Okay, which causes that pressure on the wall from inside, not from outside. So that is called turgor pressure. Suppose this is cell. Okay, so water enters the cell. Before entering of this water, there is no turgor pressure. Okay, this is a normal shaped cell. Fine. Now water enters. Water enters. So the cell, it slightly enlarges in the size because this turgor pressure. So cell wall is it is not stiff. It is hard. It is rigid, but it is slightly elastic because cellulose is present. Okay, so it will not break, but yes, slightly enlarges in size. So cell enlarges, and this enlargement is because of entry of water molecules in the cell. So these are water molecules. These water molecules actually they exert one pressure on the wall. Okay, so water moves inside the cell because of endosmosis occurs, and these water molecules they exert one pressure on the wall, and it causes, because of this pressure, the cell becomes turgid. It becomes slightly large, and the wall, the complete wall, complete membrane is stretched, and that condition is called turgid cell. Okay, and the pressure exerted on the wall, that is called turgor pressure. Okay,
Sir, can you
actually this is cytoplasm. This is cytoplasm. Okay, the cell is not empty cell, it has cytoplasm. Now water enters the cell. Okay, so obviously this is the first size, this is second size, A dash. So here water enters the cell. It starts the water entry starts here because of endosmosis. So the cell becomes slightly larger than the previous position. Okay, so in previous condition it is smaller, and now it is larger. Slightly enlarges, you can say slightly enlargement occurs because of this cell membrane and cell wall elasticity. Okay, they are slightly elastic. So the cell becomes enlarged because continuous water is entering the cell. Fine. The cell, the water enters the cell and it is dissolved in the cytoplasm. So overall, this cytoplasm, or you can say the water molecules, they exert one pressure on the wall, on the cell membrane, and finally on the wall to enlarge the cell. Okay, and this pressure, it causes development of or you can say the enlargement of the cell, and that pressure is called turgor pressure. Okay, it causes that tension, it causes that stretchment of the cell. Okay, the cell or the cell membrane, cell wall, they are stretched at one point. Okay, because of increasing entry of water. Water is continuous entering the cell, and it causes
Sir,
one
can you
pressure
please
on the
scroll
wall.
up a bit?
So that is called turgor pressure. The cell become turgid now. Thus this cell become turgid. Okay, so this is turgid cell, and the pressure is called turgor pressure. On the other hand, this cell is actually plant cell. So the plant cell has cell wall. Because of this cell wall, the cell wall is slightly elastic. It is okay, but it cannot be broken down by this pressure. Okay, because this is the rigid structure, the cell wall. So the cell wall it creates another pressure which is equal and opposite to the turgor pressure. Equal and opposite. Fine. So the cell remains turgid but cannot be burst because of this cell wall. Okay. And this pressure which is produced by wall against the turgor pressure, that is called wall pressure. So this is wall pressure and this is turgor pressure. Clear? So turgor pressure exerted by cytoplasm because of intake of water on the wall. Okay, it is exerted, it is created by cytoplasm, or you can say water upon the cell wall. That is turgor pressure. In turn, the cell wall, it creates another pressure which is equal and opposite to the turgor pressure to maintain the shape. Okay, to prevent the cell from bursting, that is wall pressure. Okay, so one is turgor pressure, another is wall pressure. Is it clear? But this wall pressure, it is only in the plant cell, in case of plant cell, because in animal cell, no cell wall, no wall, so no wall pressure. Okay, the cell will burst, the cell will destroy. It will be destroyed. Fine. So here, turgor pressure and wall pressure, two terms. Just wait. Let me write here the definition first. Turgor pressure. Okay. The pressure exerted by cytoplasm, not water. Exerted by cytoplasm.
Sir, we can even say protoplasm, right?
Protoplasm, no issue. Upon the wall, upon the cell wall, due to intake of water or entry of water into the cell. It is called turgor pressure. Turgor pressure causes enlargement of the cell. Of the cell. Okay, so that is turgor pressure. The cell becomes turgid due to turgor pressure. Okay, so this is turgor pressure. Next is wall pressure. So what is wall pressure? In turn, wall exert one pressure. It creates one pressure on the cytoplasm.
Sir, can you scroll up?
Cell wall creates a pressure.
Sir, can you please scroll up? I had connectivity issues. I was not able to write.
From where? Turgor pressure.
Yes, sir, from here.
The
Thank you,
wall
sir.
pressure.
From which point? Turgor pressure.
The wall pressure means it is antagonistic to turgor pressure.
So what's the
Yes, it
last
is
point
opposite to
of
turgor pressure.
TP, sir? The cell becomes?
Turgid. 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 Because of turgor pressure. TURGID. Due to TP. TP means turgor pressure. Okay. Is it completed?
Yes, sir, I have taken a screenshot.
Okay, fine. Okay, wall pressure. So wall pressure means what? Against the turgor pressure, the wall creates, it starts another pressure on the cytoplasm. Okay. Upon the cytoplasm. Okay. It is wall pressure. It is called wall pressure. This is wall pressure. Turgor pressure and wall pressure. Just a little before this point. Wall pressure prevents the cell from to burst by entry of water in the cell. That is WP. Now turgor pressure and wall pressure, they are equal and opposite in direction. Okay. Turgor pressure and wall pressure are equal and opposite. Equal and opposite in direction. Okay. So turgor pressure, or you can say the wall pressure also. Turgor pressure, wall pressure is same, it is equal, but only direction is different. Direction is opposite. So if the turgor pressure is high, it means the cell becomes turgid. In turgid cell, in other words, the turgid cell has maximum turgor pressure. Okay. And if the cell is flaccid, suppose, it means no turgor pressure. Okay, it becomes flaccid. Or you can say plasmolized cell. So plasmolized cell or flaccid cell, they have zero turgor pressure. Fine.
Sir, once repeat.
This is turgor pressure. This is TP. The cell becomes turgid. Okay. So it is maximum turgor because this turgid point, this turgid cell, turgid. It is turgid because of turgor pressure. Now, water enters the cell, it creates pressure that is called turgor pressure. And because of turgor pressure, stretching occurs. The cell membrane and cell walls are stretched. Okay, because of continuous pressure upon the wall. So it becomes stretched. That is called turgid cell. So in turgid cell, TP is maximum. Okay, and suppose water moves out from the cell by exosmosis, so the cell become flaccid. Okay, it loses its shape, so this is flaccid, and because of this is flaccid cell, so there is no turgor pressure, no entry of water here, so no question of turgor pressure. So the turgor pressure is minimum is 0. Okay, it is 0 in flaccid cell. Fine. So it means this turgid condition depends on turgor pressure. If turgor pressure present, obviously the cell becomes turgid. If the cell loses water, it means it becomes flaccid, no turgor pressure. Clear? So here in a turgid cell, turgor pressure is maximum in a turgid cell. In the turgid cell, Tp, it is equal to OP. OP. Okay. OP means osmotic pressure. Fine. Osmotic pressure means what? The pressure exerted by solute on the wall to prevent water entry. Okay, that is osmotic pressure. And it shows the absorption power of the cell, absorption of water. So it becomes same, it becomes equal to turgor pressure. Okay, it means there is no chance of entry of water in turgid cell. Now you cannot enter the molecules of water. Okay, water cannot move in the fully turgid cell when Tp is maximum. So here OP and Tp, it is same. Fine. So in a turgid cell, turgor pressure, it is maximum, and turgor pressure, it is equal to osmotic pressure in a turgid cell. On other hand, in a flaccid cell, Tp is 0. It is 0. Okay. So here Tp is 0. Osmotic pressure is maximum. It means it is thirsty cell. No? Its power of absorption is more. There is no turgor pressure. There is no entry of water. The solution is concentrated. Okay. It means there is a chance to enter water molecules. Is it clear? Any doubt? Okay.
No, sir, no doubt.
Fine. So in turgor pressure, in turgid cell, turgor pressure is maximum. It becomes equal to osmotic pressure. No water entry is possible. Fine. In flaccid cell, turgor pressure is 0 because this is flaccid. Flaccid means what? Concentrated solution. No water entry is there. So it is flaccid. So obviously the turgor pressure is 0. No chance of turgor pressure. No turgor pressure, no wall pressure, and maximum osmotic pressure. Fine. So here there is a more chance to enter the water. Here, so this is turgor pressure, wall pressure. Now,
Sir, once can you repeat the difference between turgor pressure and wall pressure?
okay, turgor pressure, it means this is the pressure exerted by enter the water molecules or the cytoplasm on the wall. This is the wall. You can see this picture.
Yes.
You can see this diagram. So in this diagram, this arrow it shows pressure exerted by water or the cytoplasm to the wall. Okay, so it stretches the wall. It stretches the cell membrane in the wall. Fine. And the cell becomes turgid, completely tensioned, you can say. Stretched condition, not tensioned, but stretched condition is there. Maximum stretching occurs. That condition is called turgid cell. This condition is turgid. Okay. So here turgor pressure is high. Okay. The pressure exerted on the wall, it is maximum. So the cell becomes turgid now. So this is turgid cell. Turgor pressure, because of turgor pressure. The opposite pressure, because here cell wall is present in the cell, in the plant cell. So the cell wall, it exerts one another pressure. It is rigid wall. You cannot break easily. So this cell wall exerts one another pressure which is equal and opposite to turgor pressure. To oppose the turgidity, you can say. Okay. So to maintain that shape only, the wall creates another pressure that is called wall pressure. So wall pressure is equal and opposite to turgor pressure. It is against the turgor pressure.
Can you explain the second point, that is in the turgid cell Tp is equal to?
It is equal to OP, osmotic pressure. It is osmotic pressure, OP.
So the reason why this
that Tp is equal to OP.
TP is equal to OP. OP, I explained this one. OP is absorption, means power of absorption of water, na? Osmotic pressure. Now osmotic pressure becomes equal to OP, equal to TP. It means now there is no chance of entry of water. Okay, this is completely turgid cell.
Flaccid cell is 0.
Flaccid cell is in the flaccid cell, turgor pressure is 0. Turgor pressure is 0. It means this is flaccid cell, more concentrated protoplasm. This is concentrated protoplasm. So it means what? Turgor, there is no turgid cell, na? Means there is no turgor pressure. Turgor pressure means what? Turgor pressure is actually a production of water molecules. It is produced by water molecules, na? Water molecules are there. They can produce turgor pressure. If you adding some water, okay, entry of water occurs, suppose. So this concentrated solution, it becomes dilute. The cell membrane becomes stretched. Okay, and in that condition, the cell membrane becomes stretched, and now it is turgid cell. So turgor pressure increases. So turgor pressure is formed. Otherwise, there is no question of turgor pressure. Turgor pressure means what? It is because of the entry of water. If water is not entered the cell has no turgor pressure or less turgor pressure. Okay. So in plasmolized cell or flaccid cell, completely zero. Turgor pressure का कोई question नहीं है. There is no turgor pressure.
Sir?
That is zero.
Okay, sir.
Sir, in flaccid cell, you said that there is most chance for entry of water molecules, no, sir?
In turgid cell, in flaccid cell.
Flaccid.
In flaccid cell.
Yes. What is turgor pressure and what is flaccid pressure?
Just a minute. Yes.
Sir, when water molecules enter the flaccid cell, again turgor pressure increases, no, sir?
Yes. Means from flaccid to turgid condition. So it is because of water molecules. If water molecules enter the cell becomes turgid. If water molecules they remove from the turgid cell, it becomes flaccid. Is it clear? So in flaccid cell, no turgor pressure, it is 0. In turgid cell, it is maximum. Okay. So this is wall pressure and turgor pressure. The next point is diffusion pressure deficit. Just a minute. Okay, this is osmosis, turgor pressure, wall pressure. And the next term is diffusion pressure. Diffusion pressure deficit. It is called DPD. So generally we use this abbreviation DPD. Okay, DPD means here this term diffusion pressure deficit, DPD. The term was given by Mayer, first of all. It is actually a suction pressure. Means here you can say.
Sir, what is the last word, sir, after diffusion pressure?
Deficit. 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 Okay. Deficit means deficiency. Deficiency, you can say a reduction. Okay. So there is a reduction in the diffusion pressure. That is called deficit. So diffusion pressure deficit. Deficiency in diffusion pressure. That is called diffusion pressure deficit. Okay. So water molecules cut a diffusion pressure deficit. Okay, reduction in the diffusion pressure of water in the solution or in the cell. That is called, just a minute. Let me define this one. DPD is, first of all, term. Diffusion pressure deficit term was coined by Mayer. What is diffusion pressure deficit? DPD is the reduction of in the diffusion pressure of water in the solution. Okay. It is called DPD. This reduction is due to presence of solute or different solutes in the solution. Okay. In short, what is the diffusion pressure of water, pure water? So pure water का diffusion pressure is maximum.
Oh, max.
That is maximum. Okay, this is maximum. Fine. If you are adding some solute in that water, so it becomes solution. So here diffusion pressure decreases. Is it clear? Suppose this is water, pure water, H2O. Now in H2O, now in this water, pure water, if we add some solutes, so it becomes solution, no? Here dP of water means diffusion pressure of water is maximum. But after adding some solutes, okay, these are solute, large molecules, these are solute, okay. So if we add some solid in the water, it becomes solution. In solution, the dP is decreased. Okay. So in definition, I wrote dPd is the reduction in the diffusion pressure of water in the solution. Okay, in that solution. And it is because of presence of solute. Okay, one more. Suppose.
So can you scroll up just a
We are
moment?
just if we are comparing these two solutions, and here more solutes are available. So which has maximum dPd? Means in which case this is A, this is B. In which case more reduction in dP occurs. Okay.
B,
So
sir.
here in this condition,
B,
because
sir.
more solute, yes, obviously more solutes are mixed now. So that the reduction in dP, it is more in B solution. Okay. So that is called dPd, diffusion pressure deficit. This is starting of diffusion pressure deficit. Someone asked it.
Sir, is DPT directly proportional to diffusion?
No. Diffusion pressure deficit. It is actually there is a relation. There is a relation between dPd, OP. I'm coming to that point. dPd is equal to OP minus TP. Okay. Actually, dPd means in simple words, you can say this is the suction pressure. Okay. Even we use that term, suction pressure. So suction pressure means dPd. In simple word, we use another term, thirst. Okay, thirst of the cell. Fine. If dPd is higher, it means the cell is more thirsty. It can absorb more water. Means it shows a power of absorption. Okay, in that condition. So just a minute. Huh? Okay, what is dPd? dPd means this is reduction, fall in diffusion pressure of water or of a solution. Okay, then it's solvent, you can say. So water ka inside the solution diffusion pressure decreases, and this decrease is called diffusion pressure deficit. Okay, it is also called suction pressure. dPd is defined as suction pressure. It is called SP. Okay, so dPd, SP, TP, WP, OP. Okay, these are many abbreviations. So dPd is defined as suction pressure. Means it shows ability of cell to absorb water. It shows ability of the cell to absorb water. Okay. And there is a relation. There is a relation between these three terms, dPd, OP, and TP: diffusion pressure deficit, osmotic pressure, and turgor pressure. Okay. So here the relation. This is dPd is equal to OP minus TP. This is the relation. So here you can put WP, no issue. WP in place of TP. TP is equal to WP. Okay. Or DPD, it is called SP. No issue. This is SP. It is same. No, it is same. So suppose one cell is turgid cell. Okay. What will be the DPD in turgid cell? Any guess?
0.
This is turgid cell. Okay. And in turgid cell, as we know, the turgor pressure, it is equal to OP. So OP is equal to TP. Okay.
DPD are same, sir.
So the relation is DPD is equal to OP minus TP. Huh?
It is same, sir. DPD also.
It is 0. Yes, OP is equal to TP means no chance of absorption of water. Okay. No water can enter the cell. It means there is no suction pressure. It means no diffusion pressure deficit, no reduction in diffusion pressure. So DPD becomes 0. OP is equal to TP means what? It means it is turgid cell, completely stretched cell. There is no chance of entry of water. Now it cannot absorb more water. So the DPD means suction pressure, or you can say it's thirst. So now it is satisfied complete. The cell becomes satisfied. So no entry of water, 0. Okay. Means in short, DPD take it at like suction pressure or absorption of water, power of absorption of water, thirst of the cell. Fine. It becomes thirsty, it means it can absorb water. If it is completely satisfied, no chance of entry of water. So here OP is equal to TP, it means no chance of entry of water. DPD becomes 0. Now in this
Sir,
case,
can you scroll
in
up a bit?
flaccid cell, what will happen in flaccid cell?
Turgid pressure is 0.
Here flaccid cell, it means turgor pressure is 0.
0.
Thank you.
And OP is the maximum because it is thirsty. Osmotic pressure means what? It means the solutes are more in that area as compared to the solvent in that cell. It means it can absorb more water. Okay. So it becomes DPD is equal to OP. In flaccid cell, TP is equal to 0. So according to this relation, TP is equal to 0. So DPD is equal to OP. Okay. So it is equal to OP. OP means again, this is the power of absorption of water by this solution. And DPD also, this is thirst of the cell. So both are equal. Okay. It means the cell can absorb more water. Fine. This is DPD is equal to OP, and it is in flaccid. These are direct questions. In flaccid cell, what is the DPD? In turgid cell, the value of
Sir, more
DPD.
DPD means it is more thirsty, right?
Yes, more thirsty. Yes. More hungry, more thirsty. Fine. So suppose if A cell has OP is equal to 5 and TP is equal to 3, and one another cell we take B cell. As B cell, the OP is equal to 4 and TP is equal to 3, then water moves from AB to A to B, B to A, no movement.
A to B.
A option,
A to
B
B.
option, C option.
A to
A
B.
to B or B to A?
A to B.
A to B?
A to B.
What is the DPD in A? In A cell, the DPD is
2.
2,
Huh?
sir.
2.
DPD is 2. Okay. In B cell, DPD is equal to
1.
1. Okay. So which cell has a higher DPD?
A.
A cell.
A cell.
A. It means it is more thirsty, no? You said this is more DPD is equal. DPD means more thirsty. It means it has more suction pressure. It has high
B to A.
power of absorption. So water moves from B to A.
B to A.
Okay.
B to A.
Don't be in hurry. Yes.
B to A
Don't be in
high.
hurry. Okay. Just apply this formula. DPD is equal to OP minus TP. So DP is higher. It means it can absorb more water. It is more thirsty. It is more hungry now. Clear? It can eat more chapatis. It can eat more rice. Fine. So it is more thirsty. It means it can absorb water from the surrounding. Okay. And the surrounding cell has less DPD. It is only 1. Okay. So water moves from B to A. This is the answer. Is it clear?
Sir, in flaccid cell, why TP is 0, sir?
Why DPD? DPD is equal to 0 now.
In flaccid
in flaccid cell. Flaccid cell, it means what? It means DPD is equal to 0. Not DP is equal to 0. This is TP is equal to 0, not DPD. Okay. In flaccid cell, there is no entry of water. The protoplasm is concentrated. Okay. Suppose this is the concentrated protoplasm. Concentrated protoplasm means here less amount of water, more solid is present. So there is no chance of stretching of the cell wall, stretching of the cell membrane, because this turgor pressure, this stretching, it is because of turgor pressure, and turgor pressure is produced by water molecules. But the cell has no water molecules or less water molecules. If water molecules enter the cell, then turgor pressure starts. Means turgor pressure is developed. Okay. Otherwise, in flaccid cell, there is no chance of turgor pressure. Only OP can be more OP and DPD. So you can say OP is high or DPD is high.
High.
Okay, because it is thirsty. Means in short, you can say concentrated cell, it is more thirsty. It means more DPD, more OP. If a turgid cell, if a dilute solution is there, it means no DPD, no chance of water molecules entry. Okay. So DPD is 0. DPD is 0. Just TP is high at that time in turgid cell. So these are some questions, direct questions.
Sir, we can even say like the place where is more solute, there is more DPD.
Yes. If you are adding some, suppose in that case, this is OP is high. In that case, A cell has more OP. If you are increasing more solute here, so this B cell has more OP than A. It becomes 6. Okay. Then the condition will be changed.
Yes, sir.
Fine. Now
So,
water
yes,
moves from A to B. So if you are adding some solid, it means you are increasing concentration of the solution. Concentration of solution, it means osmotic pressure increases. Osmotic pressure increases, it means the cell becomes flaccid. Okay, so DPD increases.
Yes,
it
sir.
becomes more thirsty. Fine. This is DPD. It is not given in NCRT, but in NEET generally we teach this part. Okay,
So
next,
what is reverse osmotic pressure, sir? Reverse osmotic pressure.
Just reverse osmotic pressure. That is in case of, let me check this one. I forgot the definition. Reverse osmosis occurs, correct. That is in some cases, let me remember this term. Reverse osmosis and dialysis process, hemodialysis. Okay, in that case, actually, this is the concept generally we use in hemodialysis, not in plant. Let
Sir,
me
there
check
is an
this one.
experiment in NCRT, sir, that Thassalfanal experiment.
No, I have no idea. I didn't check that one. In NCRT, generally,
Yes, sir.
I use a reso material most of the time. Reso material, my own notes only. So if it is given there, I have to check that one. Okay. So I'll clear you this point tomorrow class. Generally, it is used in
Okay, sir.
hemodialysis also. Okay.
Okay, sir.
Failure. So I will clear you this.
Target pressure.
Just a minute. Yes. Water potential. Next is water potential. Water potential. Now, water potential means actually um, it is osmosis also, but in term of energy. Fine, that is called water potential. Means this is again movement of water, but in terms of free energy. That is called water potential. Here, if I say this is actually if we are putting two different solutions, okay, so this is the difference between the energy of free energy of water molecules in pure water. Just a minute, let me define here. This is pure water, no solid is added. Okay, pure water is there. This is pure water, and this is the solution. Some solids are there, solid molecules. So this is solution. Now water molecules move from this pure water to solution. Okay, as we know. But here the definition is slightly different. Here it says the pure water. The pure water has more free energy. These molecules, they have more free energy. Okay, but this free energy, it is decreased if you add some solutes in water. So this free energy is decreased as compared to the pure water. Fine. So this difference between two free energy between pure water and its solution. Okay. So water moves from high free energy region to low free energy region. And this difference between two free energy, that is called water potential. Okay. So in short, this is the difference between the free energy of pure water and the free energy of water in the system, in the solution. It is called water potential. Am I clear? Are you getting me?
Yes, sir, we are getting you, sir.
Again, I repeat this point.
Can you repeat it?
What is water potential? Yes. Water potential means actually this is pure water. Okay. In pure water, the water molecules, they have high free energy. Obviously, they have high free energy because there is no solid molecules present. Now, in another step, if you form one solution, okay, solution means what? You are adding some material, you are putting some materials, solute materials in the solution, in the water. So it becomes solution. In the solution, the free energy of these water molecules, these are water molecules now. So these water molecules, they have less free energy than the water molecules present in pure water. These are also water molecules. Huh? This is not solution. So they have high free energy, and these water molecules, they have low free energy. So this difference between energy of solution, this difference is called water potential. Is it clear? And now here, yes, water moves from high concentration, high free energy to low free energy. So this is actually osmosis, but in terms of energy. Okay. So generally water moves from the region of high water potential. One more thing. Here the water potential is higher. This is WP, high, where free energy is high. Okay. So water moves from high water potential to low water potential. Here this water potential, it is not WP means it is not wall pressure. Huh? Water potential higher in this pure water, and water potential is low in solution. So you can say water moves from high free energy region, high water potential to water potential. Okay. This is water potential. This is also same diffusion like phenomenon. And here one more, water potential of pure water, it is maximum. Water potential of pure water is maximum, and it is 0. And it is 0. Okay. This is maximum water potential, but water potential maximum but 0. It means what? It means in the solution, the free energy decreases. Obviously, the water potential becomes less than 0. It becomes negative. Is it clear? So maximum water potential is 0 in pure water. Okay. Generally, they ask simple question. The pure water has maximum water potential. What is the value? So maximum means what? Maximum is 0 only. Huh? 0. If we are adding some material, it becomes negative, less than 0. So solutions, any solution, it has negative water potential. Okay, but pure water has maximum water potential, and it is 0. Yeah. So these are some points related with water potential. We will continue this part tomorrow, and I will explain that point. Who asked about reverse osmotic? Reverse osmosis, Tarun?
Preetham, sir.
Preetham, okay, fine.
Yes.
Thank you, sir.
Thank you, sir.
Thank you,
Yes, sir.
Thank you, sir.
So,
Thank you, sir.
any question related to
Thank
this?
you, sir.
Thank you, bye. Thank you.
sir.
Any
Thank you,
question?
sir.
No, sir, no
Or should I
question.
close this one? Okay,
Thank you.
Yes, sir.
No doubts.
fine.
Without
Okay, thank you. So I'm going to end
Thank
this
you,
meeting
sir.
here. Thank you. Thank you.
Sir.
Thank you, Vidhi.
Sir, I have a
Thank you,
doubt.
sir.
Thank you, sir.
So the study of tissue is called histology. Then the histology name is given by the mayor, right, sir?
Yes, Mayor. Correct, Mayor.
Okay, sir. Thank
Mayor
you.
is the biologist. No?
Ah,
He
yes,
gave the
sir.
term histology. Yes.
Sir, what's about sheets and DPP?
Your sheets and DPP, I have no idea about this. Better to ask the office directly. Okay.
Sir, any homework?
Yes, sir. Any homework? DPP or sheets?
No, actually, I have no DPP. Fine. I have just my notes here. So homework in photosynthesis. Sorry, in this plant. Just go through this diffusion, osmosis, and active transport. Okay.
Okay, sir.
Diffusion,
Okay, sir. Thank you.
active transport, and osmosis. Thank you.
Yes, sir. Thank you.